Okay, this session is considering bioacoustics monitoring, a survey and research tool, and it's going to be looking at an overview of bioacoustics and how it could be implemented into different research scenarios. I'm not kind of going to go into too much detail about specifics, but to give more of an overview rather than anything else. So basically, what is bioacoustics? Well, in effect, it's the science of sound produced by living organisms, I suppose. And what I kind of found from a quick Google search of various free online dictionaries is basically it's a combination of two disciplines. So it's a combination of biology and really physics when it comes down to it, or even the arts, if you want to put it that way, because what you are is a sound engineer as well as a biologist. So it's generally that you've come from one of those two backgrounds. You've either come from roughly a biology background, or you've come from a kind of a music type background, and you're kind of putting the two elements together. So everybody is learning all the time when it comes to bioacoustics, because we're always learning about the other subject we didn't study from the beginning. What do we mean by bioacoustics? Where's it applicable? Well, really, it's just another survey method. It's something to throw into that toolkit that we have. So there's a few examples here of all the other survey methods that we often implement when we're doing surveys for different species. So we've got tracks and signs, trapping, radio tracking, DNA, actually going out and physically doing surveys. Camera traps, this cool picture of a bear is a camera trap of a bear eating one of our old SM2 detectors. So we were trying to work out what was eating it. It was a bear. But it's the idea that it's used in conjunction with other survey methods, not necessarily standalone, or there are applications, though, for standalone surveys using bioacoustics. So what information can we get from bioacoustic surveys? This is not a definitive list. This is just kind of what I suppose the common research projects and survey techniques kind of identify. But things like presence, absence of particular species, population dynamics, behavior, species assemblages, breeding patterns, social interactions, and soundscape studies are kind of just some of the areas that we kind of focus on, I suppose, when it comes to bioacoustic surveys. But please go beyond this. The benefits of using bioacoustics, I'm very bat biased, hence the picture of a bat. But generally, what we tend to find when using bioacoustics as a research tool, it reduces disturbance. It's not invasive. It allows you to monitor inaccessible locations in a cost-effective way, and you collect data on other things as well as your target species. If you're doing a survey on owls and you're putting a recorder out to record owls at night, you are going to get other things as well as owls. So you may have actually recorded enough information for 5 or 6 research studies. Obviously, using conjunction with other techniques, we can use it to calculate things like biodiversity richness, using something called acoustic indices to calculate that. Very good for nocturnal species, bat biased. In the bat world, we've been using bioacoustics for a very, very long time, just because the little pesky things come out at night and they make these really high frequency noises that we can't really sort of detect unless we have a bat detector. So for a lot of bat species, they work really well, but things like nightjar, owls, a lot of nocturnal birds, it's exceptionally useful. Migratory animals, we never know when they're going to migrate, so put a detector out, we might be able to capture animals migrating at a specific time or location. The cool thing is that data can be revisited. We don't have to just rely on that, using that data once. It can be challenged. Generally, it picks up a wider detection range than other survey methods as well. We pick up a bubble of sound rather than something that's visually focused. And we can cover a broader taxonomic range. Other techniques, the equipment's now easy to deploy, and we can leave it in situ for a very long period of time. We can also sample data as well. We don't need to use all the data. So from an equipment perspective, there's lots of bits of equipment out there. You've all got a piece of equipment in your pocket that's capable of recording sound. You know, we've all got a mobile phone. There's a free app that we give away called Song Sleuth, which is a really cool kind of birding recording app. You might have got old recording techniques, and you can go to the other end of the scale and get sort of a parabolic microphone that you can stick out in the field. But generally what we're talking about when we're looking at bioacoustic recorders is long-term monitoring. And so things that are fixed out in the field. So the two images on the right are two of our acoustic recorders for recording birds and such. And this kind of variance and there's trade-offs between active, going out in the field with an actual recorder, and passive. But generally it's that reduction in disturbance. It's letting a machine do the work for you and not having to stand out in the freezing cold trying to look camouflaged so things are acting in their normal way. Deployment techniques in practice. This is me, by the way, looking fairly terrified. But deployment techniques in practice, I'm not going to go into in too much detail because it's really project dependent. You know, am I putting one recorder out or 100 recorders? But there are publications which do help with looking at those deployments. This is a bat publication by the Bat Conservation Trust. There's several publications on their website, well worth a look, and you can apply this guidance that they use into kind of a lot of situations, not just bats. You can look at daytime kind of species as well, and non-ultrasonic species. The actual principles are very much interchangeable, and especially when we're getting things like what the Bat Conservation Trust is trying to get out of bioacoustics are things like, are bats present or absent? It's that original list, you know, what are the activity levels like? What are they using the site for? So they do kind of hone in on those specifics. In fact, one of the tables within the current guidance looks at using transects, so transects with a handheld detector or static detectors, and what are the benefits of each. And really some of the main benefits on actually going out and physically doing a survey is the texture that you get from your surveys. You know, you get observations like behavior and things like that. But the things that the disadvantages are you can only be in one place at once, you know, as a human being, where if we put automatic detectors out, we lose that texture, but we get stats in effect, things that we can use to make pretty graphs. Another publication looking at acoustic monitoring is this by the World Wildlife Fund. If you just put in a Google search bioacoustic monitoring WWF, this publication will appear. It's really a really good how to start doing bioacoustic monitoring. So it's a really good from the sort of grassroots. Okay, that's bioacoustic monitoring. What about analysis? You know, you're going to get a lot of data. To put it into perspective, 1 hour's recording on CD quality, so just acoustic data, is 380 megabytes. That's going to be a lot of stuff to analyze. And what are we analyzing? You know, are we looking at an assemblage or specific species, or are we looking at a broader scale, like a soundscape kind of interpretation? Basically, the whole thing relies on identification. And from that species identification, there has to be a level of expertise, you know, but on the outputs of that, we get really cool things like the time and date of each song or call or whatever we're recording, which is making that data quantifiable. The trick is processing that data quickly. So when we look at a level of expertise, birds or mammals or whatever you're recording, insects, tend to have their own signature, their own identification. Here's a couple of examples here. If you're looking from a more generic perspective, if we're zooming out, landscapes also have their own signature, their own identification. So these two landscapes here, Barcelona and Bamford, my little sleepy village near where I live, you can see there's a definite signature between these two landscapes, this urban and rural environment. Take it even further, what about this? This is a secondary forest in Borneo. basically what you're seeing here is lots of different insects making lots of different noises at night, but you can see they've all got their own acoustic niche. The thing is that how do we pull this data out from our data set? We could have hundreds of hours worth of recording. We can go line by line. We can go through each individual call and identify them, but that's not really a practical way of doing things. But we offer some software called Kaleidoscope Pro, and what that enables you to do is to do things called cluster analysis, and in effect basically build a classifier to pull recordings out from your data set. And how kaleidoscope clustering works, it gets all the vocalizations, it looks at all your data, it gets all the vocalizations that sound the same and groups them together. So instead of labeling one particular call, you're labeling a group of calls. So here I've got a little video, and this is a batch of data, and it's a serious batch of data. I've got 144,000 vocalizations, and it's grouped them together in 370 distinct vocalization groups. So if I go back up to the first vocalization, and I go through line by line, we can sort of see that each of these vocalizations are the same. And what I can do, I can play those vocalizations so I know what I'm kind of looking at. I can look at it in context. I can look at the time before and the time after. So if it's a string of vocalizations, but more importantly, what I can do is I can label these vocalizations. I can give it a tag, you know. So here we go. I shall ID this, and I've called it something very imaginatively. I've called it bird one, and it's identified bird one. Now, some of these vocalizations may not be correct, but the majority of them will be correct. Okay, and then I can maybe go back and look through line by line to make sure I've got all my vocalizations right. The output of that is a CSV file. And so a CSV file, we can do whatever we want with a CSV file, especially when we have the time and date of every one of those vocalizations. We can do things in R or Excel or whatever stats package you kind of favor. But in general, the output is a CSV, and that makes life so much easier. So really, in conclusion, what bioacoustics are, it's another tool within your survey toolkit. It's going to cover a wide range of applications, and I want you to think about what those applications could potentially be, not me. I'm a mere bat biologist. But other things are deployment over long periods of time. You're going to get a huge number of data points, but there are methods out there to go through this data very, very quickly. Thank you very, very much for listening.
Most people have a good idea of what a healthy farm looks like. Abundant growth. Lots of colors. Most people could even tell you what a healthy farm smells like. But what does a healthy farm sound like? One of the most audible natural features on a farm or in any outdoor space is bird song. It's an easy way to tell an urban or suburban area apart from a forest. But what can bird calls tell us about agriculture? Birds, much like any other animal group, provide us with ecosystem services. Birds provide pest control by eating bugs, diminishing the need for pesticides. Birds also create a far more welcoming natural environment. You might not notice them every time you go outside, but you would definitely notice if they weren't there. But what do birds get in return? How do birds depend on agriculture? Healthy farms provide a lot of the things a bird population needs to flourish. Heterogeneity of crops, crop rotations, and other regenerative farming techniques better simulate the natural environment. helping birds feel at home and maintaining a desirable level of biodiversity. Dr. John Quinn of Furman University is doing just that in his research, focusing on audio data. Using 39 different sound recorders, Dr. Quinn has been able to assess the impact different farming habits have on bird population and diversity.
For the project, we're building on past efforts by General Mills and collaborators looking at how different farming practices affect biodiversity. In particular, we're using automated recording units to sample continuously throughout the season for bird abundance and bird diversity. We can listen to each of the individual audio recordings and take note of what species we hear. There are 4 different recordings up here. I'll start by showing, and we can listen to one farm that has relatively low biological diversity. In fact, when we listen to it, we actually don't hear much at all. But this is a farm that, at least based on this recording, does not necessarily provide a lot of habitat or a lot of space for particular species. We can contrast that to our file here in the top right, where we hear birds in the background. The most prominent one is the dickcissel, which is also the species that we see most visually with these kind of long sweeping up. If we listen to this one, there are also bobwhites in the background. Occasionally we hear a ringneck pheasant, and a diversity of other species in the background. So this one, this farm, based on the acoustics, is providing more habitat, more foraging opportunities, more nesting opportunities for different species of bird. Often agriculture is seen as, only providing one or a limited number of benefits to society in production, in particular the production of food. However, agricultural practices and regenerative agricultural practices can support and contribute to larger conservation goals.
The next time you're on a farm, take a few minutes to stand still. What do you hear? Do you hear a healthy farm with abundant bird song from different species? Listen carefully to the land and learn what it has to say.